All right. So hello everyone. This is me Sayed Umair Gilani, and today I just want to talk about my framework, which I have written purely in C, and this has to do with implementing the transformer architecture right from the scratch. And I'm calling it a framework because I have every right to do so. I just literally implemented everything from scratch, the way PyTorch or Jack or TensorFlow does, implementing my own tensors library, having all the required methods, which has to do with the mathematical modeling, statistical modeling, and everything. Helper functions like tensor multiplication, softmax, logarithmic exponential functions, and everything. So yeah, it took me around 3 months, and I've worked days and nights for this. I've gone through a lot of research. I've read lots and lots of articles, um, lots of research papers. I've read about on Wikipedia, and also I took help from ChatGPT and large language models in this regard. So it was like a great journey. I just wanted to open the black box of how large language models work and everything, right? So enough of the rambling. Let's get right into the stuff. So as you can see on my screen right here, this is my repo, mini torch. I just want to call it mini torch for some reason. I don't know why. Might be one day this competes PyTorch maybe. Let's be optimistic. So yeah, I just want to call it mini torch, and so here actually is all these files which I've worked at, um, and you can see some training loss curve which I just recently I yesterday just take a sample data of 16,000 observation, which is really small, and I just having embedding size of 32. I just wanted to train a model and then run the forward pass, run the backward pass, update parameters, um, run optimizations, scaling, layer normalization, everything, and then just keep on decreasing the loss, right, until I achieve the convergence. So this is actually the loss curves, and you can see I've implemented mean squared error loss for now, not cross entropy for some reason, just to make things simple, because this is an you can see in education projects for now, but later on we'll change this loss to a cross entropy in which actually is used in transformers, right? So yeah, 1000 epochs loss, and you can see loss started around 34, 35, and at the end we had like under 10, like maybe 7 to 8, and if I had more data it would have kept on going down and down, right? So yeah, you can read about this repo. These are actually the main files, tensor.c, which has all the helper methods regarding tensors. Uh, and why don't I just go ahead and run this for now, just to give you an idea how these things work actually. So we'll come back to the files later. So first of all, I just wanna run it here to give you an evidence that I've done this from scratch, and this is not actually some random image. This is actually coming from a transformer model written purely in C, right? This is the important part, in C. Let me tell you, nobody has written this in C, by the way. Not even PyTorch, not even transformers. Transformer library transformer model is written in pure Python with some C functions at the low level. Andrij Karpathy, this guy has written some part of this in C, which is actually a minimal runtime, which is not really a full-fledged framework, by the way. I'll show you in the series of videos later that how I'm calling it a full-fledged framework, and it's scalable. Well, this guy's one is not scalable. The one I'm talking about, llama.c. It might be somewhere here. This is not. This is llama2.c. Sorry, it's llm.c from Andrij Karpathy, right? And it's actually basically a smallest runtime, which the purpose of which is just to run a large language model, to train a large language model in minimum C code. It's very optimized as well. Mine is not that optimized, to be very honest, but my one is very scalable, and which I'll be working on later for optimizations. Okay, yeah, this is here, right here. You can check this out later, but right now I won't cover this in this video. So coming back to my one. All right, so we were actually running our model. I hope you can see my screen, the terminal as well. Okay, so I think this might work. Okay, let me just fit it to my screen. Okay, so I'm gonna cd to github ml. I need to change this name, by the way. Um, and ls-lt, which is the last file I worked on. Okay, so I generated this linear curve right here, and this is actually my repo. All the files you are seeing right here. Okay, so let me open the run.sh, and in run.sh I have all these files linked. And let me just run this run. Okay, run.sh, and you can see it has started actually training our model, and you can see the loss is decreasing over the epochs, and the loss was started from 33 to it's going down and down, and it'll keep on running. uh yeah, so it's already achieved on the 50 epoch 8 7, so it's working in a like a stochastic way, sometimes going up and down, but it's the idea of this entire algorithm to find global minima and converge, right? So yeah, I hope you got an idea. We'll come back to this later. So I was introducing to the files. This is actually the tensor file, which is all the methods written related to tensors. For the sake of just just to have a glance, we can actually see it. Okay, so tensors.c, and if I go ahead, so we have all the field zeros, tensor in place. We have check tensor check, and yeah, and this is actually gradient clipping. I just wanted to see if the gradient is going out of the bounds or not, and if it is, it just checks that whether the gradient is just exploding or not, right? So it just checks the tensor, tensor scalar multiplication, tensor scalar addition, tensor add. So these are all the methods that you can check later. Uh, I was just introducing you to this file. Okay. Moving back, we have attention.c, which is probably the most important file. This is actually the most important file, which applies um, forward multi-head attention and backward multi-head attention. So it's if I just open as htn.c, so nothing is structured yet. I'll make it as structured because this is, inshallah, this will be transforming from educational project to full-fledged mini runtime, right? And to all the guys who are interested in like implementing low-level algorithms, I'm cordially inviting you all to come and participate and sponsor, give it a star, fork, um, you know, if you wanna just take this to next step forward. And if you think that you have good idea of how you can actually optimize this, you're welcome to commit. You're welcome to just fork this repo, clone it, and start contributing, right? Okay, so I was opening this attention to.c. I'm sorry if I'm speaking too much, by the way. I'm really, really excited to show you, and to all the guys who are interested in low-level work and C, and implementing this entire thing right from scratch, and then back propagating and then updating optimizers, and then working this loss smoothly work, making this loss very smoothly work in pure C, and who have done all the experimentations and research, might know why am I very excited for this. Okay, so these are actually so tensor softmax gradient. This is actually this takes the gradient of softmax. By the way, I should not have written this here. Like I said, there's not a structure. I'll be refactoring this code later, inshallah, to and moving these functions to relevant files. This is actually a weight substitution algorithm function, which basically takes this it calculates this derivative of attention and derivative of value matrix, attention matrix and value matrix. So this has to do with um, yeah, I'll explain these things later in some other video. But by the way, this is actually QD times K. This A is basically QD times K multiplied by under the root of dk, right? And this is actually the attention. And then when it gets multiplied by values matrix, we have um, self-attention completed, right? So I hope you're able to, this is the first part and this is the second part. So this session gets multiplied with these values to get the full um, self-attention matrix, right? Okay, so this is my backward parse. Probably the most difficult function was this one, MHA backward. And you can see it takes the dx tensors tokens and backward propagates and finds the finds the using the chain rule finds the derivative of multi-head attention, and then returns a tensor at the end of the size 16 cross 32, which was actually my um, matrix size over here. Later on we can just scale it as well. So this is actually for method, and you can see this later, how these functions are interconnected and how actually this entire thing works. Okay, so this was the second file, and then I have ln.c. I'll not be opening any files because I'll cover this too in some other video. ln.c means layer normalization, implements forward and backward paths. So you can see everything is structured. I've created X structure for every single layer. So first the structure is first is abstract for tensor. The second is abstract for attention heads, which implements multi-head attention. The other one is ln.c is basically layer normalization attentions. Um, Layer normalization, and ffn.c is fully connected neural networks. And what is this? Yeah, so basically it contains the attention structure and relevant methods, prototypes, and same goes for tensor and layer norm and for neural language. So main is the one that calls everything, that binds everything together, right? This is actually the motivation, what compelled me to write this, and this is actually something that I implemented. And yeah, you can read these things later to get an idea of how everything was working. I'll be like updating this repo page um, on daily basis for you to have an idea in case if you want to deeply understand how did I manage to implement all these things, right? So for now, I just implemented this stochastic gradient descent, which stochastically finds the gradient. In case if I can show you, so let me run this again. As you can see, if I just close it, you see that first we had 34, then 33, 31, 31, 29, and then 32. So it coming down and coming up again. So that's how that's how oscillating the stochastic gradient doesn't work, and it tries to find the um, global minima. And this has to do with the learning rate as well. Let's see, what was our learning rate? Our learning rate was actually LR, 1 milli test power negative 3.001. Yep, that's right, 0.001. So I started small, and then it's always a great practice to start small, the learning rate, and it smoothly finds the global minimum, right? So yeah, this was for educational purpose, and these are actually the references. I implemented this model from attention's all you need, and inspiration is this guy. Yeah, Andrej Karpathy. Not only this one, but also George Hart, written Tiny Grad, also in Python. Mind you, Python. There's a difference between Python and C. Always remember, folks. Python is something else. C, as something at some other level. I'll talk about this later. What are the challenges in C? But yeah, so here's your author, and in case if you want to contribute to this, you're more than welcome. In case you want to check out my LinkedIn, it's right here. You can check it out. Feel free to fork this repo, clone this, do some changes, generate a pull request, and I'll happy to check that out. Thank you so much.